Good day everyone. Today we're going to discuss some of the machine tools that every mechanical engineering student should know. The discovery of milling, shaping, and planing machines changes the world of machining and manufacturing, transforming raw materials into precisely built products and components. These devices have a long and interesting history that began in the early stages of the Industrial Revolution. The need for mass-produced goods at reasonable prices led to the advancement of these machining techniques. So let me share to you the brief history of the mentioned machine tools. Let's start with the planer machines. Planer machine was developed in the early 19th century. It was primarily used for producing flat and smooth surfaces on large workpieces. James Fox of Derby, England, is credited with building one of the earliest planing machines in 1817. Richard Roberts, an engineer from Manchester, England, made significant contributions to the development and improvement of planer machines in the mid-19th century. Next is the milling machine. It evolved from the planer machine. It emerged in the 19th century and became a crucial tool for machining operations. Eli Whitney is often credited with inventing the first milling machine in the United States in 1880. The development of milling cutters and the ability to move the workpiece in multiple directions led to the versatility of modern milling machine. Last is the shaper machine. The shaper machine was developed in the mid-19th century and was used for machining flat surfaces and creating shapes on workpieces. James Nasmith, a Scottish engineer, is credited with inventing the shaper machine in 1836. Nasmith's shaper machine utilized a reciprocating motion to achieve its cutting action. And these machines played pivotal roles in the Industrial Revolution, enabling the mass production of precision parts. They have since undergone numerous refinements and advancements, but their fundamental principles and functions remain influential in the modern machine processes.
And now I'm going to discuss to you some of the introduction of shaper, planer, and milling machines. Over the years, these devices have evolved from the basic hand-operated instrument to extremely complex computer-controlled systems, revolutionizing the industrial sector and making it possible to produce precise and complex parts in large quantities. Understanding their capabilities and application is fundamental for any aspiring engineers or machinists seeking to master the art of material fabrications. With that, in these topics, we will explore the fundamental principles and characteristics of these machines, illustrating their importance in modern industrial processes. Machining devices have undergone remarkable transformations from simple hand-operated tools to computer-controlled systems, ushering in a profound revolution in industrial realm. This evolution has enabled the mass production of intricate and precise components. To master the craft of material fabrication, it is essential for aspiring engineers and machinists to comprehend these machines, capabilities, and applications. In these discussions, we will delve into the fundamental principles and distinctive characteristics of these devices, shedding the light in their pivotal role in modern industrial processes.
So now, we are here to discuss the objective of this group report. It is to provide practical understanding of planner, shaper, and milling machine during workshop operations. More specifically, it intended to do the following: to analyze the fundamentals, principles, and operational mechanisms of milling, shaping, and planning machines, to explore the diverse applications and roles of milling, shaping, and planning machines in manufacturing technology, to assess the impact of milling, shaping, and planning machines on manufacturing efficiency and quality. So those are the objectives of this group report.
First type of machine is planer machine. Planer machine is a sturdy equipment used to remove materials from workpieces with great accuracy to obtain flat and smooth surfaces. This machine is commonly used in workshop and manufacturing sectors like metalworking, woodworking, and production of massive and heavy components. Planer machine is vital in machining operation due to its ability to handle large workpieces. Working principle of the planer machine. The workpiece is firmly held or mounted into the machine table of the planer machine, while the single point cutting tool is correctly held to the tool post coupled to the reciprocating ram. The ram's reciprocating action is produced using the rapid return motion mechanism, which ensures smooth back and forth movement. The cutting tool contacts the material during the forward stroke of the ram, removing material to shape the workpiece. The return stroke, on the other hand, has no cutting action and is referred to the idle stroke. The idle stroke allows cutting tool to orient itself for the next pass without cutting into material, reducing wear, and promoting efficient machining. Planer machine is well known for their ability to handle large workpieces and produce precise, accurate, and flat surfaces. Parts of planer machine. First is the bed. The bed is a sturdy foundation in which all other machine parts are connected or mounted. Second is the columns and housings. These are rigid box-like vertical structures that are connected to the sides of the bed and firmly attached to it. We also have here table. This supports the workpiece and moves along or reciprocally along bed's base. We also have cross rail. Cross rail features tool holders for in which cutting tools can be fixed. Next is tool head. Tool heads is responsible for holding and securing cutting tools. We also have vertical tool heads in which it moves left and right, and horizontal tool head in which it moves up and down. We have five types of planer machine. First is the standard or double housing planer machine. It features long and robust base with a table reciprocating on precise guideways. The bed's length is slightly more than twice the table's length. Two massive vertical housing are positioned near the middle of the base, one on each side of the bed and firmly attached to it. The second is the open side planer machine. This machine has housing on one side of the base, and the cross rail is suspended from the housing as a cantilever. This unique design enables large and wide workpieces to be clamped on the table and reciprocated over the cutting tool. Third is the pit planer machine. This machine has pit bed that allows the table to descend to a lower level to handle tall workpieces. This design allows it to use for machining operations with various height and increased versatility. Fourth is the edge or plate type planer. This machine is intended primarily for planing the edge of lengthy plates or sheets. It has a small table and appropriate tool heads for precision edge. And last but not the least is the divide table planer rather. This machine features a segmented table that may be individually adjusted to different levels. This allows for the simultaneous machining of many workpieces, increasing productivity and decreasing setup time. And of course, planer machine has its own advantages and disadvantages. For its advantages, it provides exceptional surface finish on workpieces. It is also low maintenance, provide great precision and consistency in machining job, can accept two or three tools, has versatile tool usage, and of course can handle big and heavy workpieces. And for its disadvantages, of course, planer machine has high initial cost, limited tooling options. It also requires qualified and experienced workers, consumes more electricity during operation, and have somewhat big footprints. Application of planer machine. Planer machine can be applied in excellent flat surface generation, efficient material removal, versatility in cutting slots and grooves, angled cutting capabilities, handling large work pieces, of course, and improve accuracy. And last but not the least is stable and rigid construction.
So, what is a shaper machine? A shaper machine is a kind of machine device that utilizes straight relative movement between the workpiece and the solitary cutting instrument toward a direct toolpath. It is utilized for creating level or vertical surfaces. The workpiece is fixed on the table and the smash holds the single point cutting instrument. During the forward stroke, the single point device joined to the slam and the workpiece is fixed on a table. Main parts of shaper machine. Base. The base is the foundation of the shaper machine and supports all other parts of the machine. It is made of cast iron and has high shock absorbing capacity. Column. The column is mounted on the base and supports the reciprocating ram and the workpiece. It is also made of cast iron and serves as the casing for drive mechanism components such as gear mechanisms, pulleys, and etc. Guideways. Two guideways are present at the top and side of the column. The ram moves on a guideway present at the top of the column, while the table moves up and down in another guideway present at the edge of the column. Table. The table is a metal body that slides up and down in the direction of the column. It holds the workpiece and the vise is placed on it to fasten or hold the workpiece properly. Vise. The vise is present on the table and has two jaws, one movable and one fixed. It is used to hold or fasten the workpiece properly. Ram. The ram is built to the left and right in the guideway of the column with cast iron and slides reciprocally. A single point cutting tool is attached to it that retrieves and rubs the workpieces and removes unwanted metal from them in the form of chips. Working principle of a shaper. The working principle of a shaper machine is based on the quick return mechanism. The workpiece is fixed on the table and the cutting tool is mounted on the reciprocating ram. During the forward stroke, the cutting tool removes material from the workpiece, and during the return stroke, it moves back to its original position without cutting. The cutting tool is fed into the workpiece by a mechanism called the crossfeed. The crossfeed is mounted on a saddle that moves along the guideways of the machine. The depth of cut is controlled by adjusting the vertical position of the cutting tool using a mechanism called the downfeed. The following steps describe how a shaper machine works. 1. The workpiece is fixed on the table. 2. The cutting tool is mounted on the reciprocating ram. 3. The motor drives a gear mechanism that converts rotary motion into reciprocating motion. 4. The reciprocating motion of the ram is guided by two vertical guideways present on either side of the column. 5. During the forward stroke, the cutting tool removes material from the workpiece. 6. During the return stroke, it moves back to its original position without cutting. 7. The depth of cut is controlled by adjusting the vertical position of the cutting tool using a mechanism called the downfeed. 8. The crossfeed mechanism moves the cutting tool across the workpiece to produce flat surfaces, grooves, slots, and etc. Shaper machines are classified based on the type of driving mechanism and ram travel. Here are some of the most common types of shaper machines. Standard shaper. This is the most commonly used type of shaper machine in the industry. It is used to produce horizontal, vertical, or flat surfaces. Vertical shaper. This type of shaper machine is fitted with a rotary table that enables curved surfaces to be machined. Horizontal shaper. The ram of this type of shaper machine moves in a horizontal direction and is used to produce horizontal surfaces. Universal shaper. This type of shaper machine can be used to produce any angle or contour on a workpiece. Geared shaper. This type of shaper machine uses gears to transmit power from the motor to the ram. Crank shaper. This type of shaper machine uses a crank mechanism to convert rotary motion into reciprocating motion. Following are the advantages of shaper machine. The cost of the shaper machine's single point cutting tool is low. In this machine, the workpiece can be held conveniently. Using a shaper machine, flat or angular surfaces are easily produced. The shaper is very simple to set up, and switching out the tools is also simple. The advantages of shaper machine include the following. First, cutting speed is not particularly high. Lastly, you can fix just one cutting tool. More than one cutting tool is not an option. Application of shaper machine. Following are the applications of shaper machines. First is to produce the straight and flat surfaces on the workpiece. Second is to smooth the rough surfaces. Third, it is used to create an internal partition or splines. Fourth, it is used in making gear teeth. Fifth is that shaper is used to make dovetail slides. Lastly, to produce keyways in pulleys or gears.
What is the milling machine? A milling machine is a type of machine tool that is used to shape and cut different materials, most commonly plastic, metal, or wood. It works by utilizing a milling cutter, which is a spinning cutting tool, to remove material from a workpiece. There are several different kinds of milling machines, including CNC or computer numerical control milling machines, horizontal milling machines, and vertical milling machines. They are frequently employed in machining and manufacturing processes to produce precise parts and components. What are the major parts of a milling machine? The base of a milling machine is the foundation, providing stability and support for all other components. It is typically made of cast iron or welded steel and houses the other machine components. The column, a vertical structure, supports the knee and other major components, providing rigidity and alignment. The knee is a vertical adjustable component that moves up and down along the column, allowing adjustment in the vertical positioning of the work table and workpiece. The saddle, mounted on the knee, moves horizontally along the way, supporting the table and allowing longitudinal movement of the workpiece. The table supports the workpiece and can be tilted at various angles for angular milling. The arbor, a tool holder, secures the cutting tool and allows horizontal movement of the spindle. The milling cutter is the most important part of a milling machine, performing various milling operations. The working principle of milling machine. Milling machines are precision and adaptable manufacturing tools that can perform various milling processes, including face, end, and slot milling. They are mounted on a spindle that can be adjusted vertically and horizontally, allowing for precise shaping, cutting, and surface finishing. The work table or workpiece is moved in relation to the rotating cutter, which can be controlled manually or through automated system like CNC. The process repeats until the workpiece has the required size, shape, or surface finish. And now for the different types of milling machine. There are several different types of milling machines, each designed for a specific machining task and application. The main types of milling machines include: first, the vertical milling machine. The spindle in a vertical milling machine is oriented vertically, allowing for easy and precise vertical and angular milling operation. They are commonly used for the tasks like face milling, end milling, and drilling. Turret mills are a popular subcategory of vertical mill. Mills featuring a rotating turret with various tooling options. Next is horizontal milling machine. In a horizontal milling machine, the spindle is positioned horizontally and the workpiece is placed on a horizontal arbor. These machines are well suited for heavy cutting operations and are often used for producing large and heavy parts. Third, universal milling machine. Universal milling machines are versatile and can be used for both vertical and horizontal milling operation, making them suitable for a wide range of tasks. They often come with a swiveling work table that allows for a machining at various angles. Fourth, bed type milling machine. Bed mills have a fixed bed as opposed to a movable knee that provides stability for heavy workpieces. These machines are known for their rigidity and are often used for heavy-duty milling applications. Fifth, planer type milling machine. Planer mills are designed for machining large workpieces, such as those used in construction of bridges and ships. They have long, heavy-duty bed and a cross rail to support the milling head. Sixth, CNC milling machine. CNC or computer numerical control milling machines are automated and operated by computer programs or called G-codes that control tool movement and machining process. CNC milling machines comes in various configurations including vertical, horizontal, and gantry styles, and are widely used in modern manufacturing for their precision and repeatability. 7. Mini, mini milling machine. Mini milling machine are smaller and more compact version of conventional milling machines suitable for hobbyists, small workshop, and educational purposes. 8. Benchtop milling machine. Benchtop milling machines are designed to be placed on a workbench or tabletop, making them space efficient and portable for smaller machining tasks. 9. Swiss type milling machine. Swiss type milling machines are highly specialized for precision and high-speed machining of small intricate parts. They are commonly used in watchmaking and medical device manufacturing. And lastly, 10. Copy milling machine. Copy milling machines are used to duplicate or reproduce complex shapes by tracing a template or model. And now, we're here to discuss the advantages and the disadvantages of milling machine. First, the advantages. Milling machines offer precision, versatility, high productivity, repeatability, surface finish, material compatibility, customization, cost-effectiveness, complex geometry, automation, tooling options, and ease of setup. They can perform various operations such as face milling, end milling, drilling, and reaming. With a single machine, they can remove material quickly, reducing machining time and ensuring consistent result. Milling can achieve excellent surface finishes, make it suitable for smooth or polished surfaces. They can work with various materials, making them versatile for various industries. Customization allows for parts to meet the specific design requirements, making it valuable in prototyping and specialized production. Milling machines can be fully automated, reducing manual labor and increasing productivity in large-scale manufacturing. Various cutting tools are available, and once set up properly, milling machines can efficiently process multiple workpieces in a row. And now for the disadvantages. Milling machines are a costly and complex tool that can pose various challenges to small businesses or hobbyists. They require high precision and CNC models, which can be challenging to learn and operate effectively. They also require significant space, require regular maintenance, and can generate noise and vibrations. Changes to milling cutters can be time-consuming and costly. Milling machines are best suited for flat or contoured surfaces, and they generate dust and chips, which can be messy and require additional cleaning. They are energy intensive, especially in industrial settings, and their cutting tools wear out over time. The size of workpieces can be limited by the machine's table size and the spindle travel distance. Manual operation can be physically demanding, especially for extended periods, due to the need for manual feeding and adjustments. And now we're here to discuss the application of milling machine. Milling machines are essential tool in various industries including metalworking, woodworking, aerospace, automotive, medical device manufacturing, electronics prototyping, tool and die making, education and training, energy sector, custom machining, military and defense, shipbuilding, jewelry making, and architectural millwork. They are used to create precision parts such as gears, engine components, brackets, and shafts, as well as intricate designs on precious metals and gem settings. In the automotive industry, milling machines are used to produce engine blocks, cylinder heads, and transmission cases. In the medical device manufacturing, milling machines are crucial for orthopedic implants, surgical instruments, and dental prosthetics. In the electronics industry, milling machines create circuit boards, control panels, and custom enclosures for electronic devices. In the education and training sector, milling machines are used to teach machining skills and CNC programming. In the energy sector, milling machines are used to machine components like wind turbine parts and oil drilling.
In this report, we journey through the fascinating world of these machines and their cutters. We discover how they are indispensable for mechanical engineers and manufacturing specialists, providing the fundamental building blocks for the production of precise components across a spectrum of industries, ranging from aerospace to automotive and general manufacturing. These machines are the unsung heroes behind the innovations that power our world. The heart of this report emphasizes the vital importance of comprehending the working principles and mechanisms of these machine tools. It is not merely an academic exercise, it is the key to unlocking the door to manufacturing excellence. Understanding these machines empowers professionals to design components that are not only innovative but also feasible for production. It equips them to make informed decisions about selecting the right tools for specific tasks. By grasping the strengths and weaknesses of each machine, engineers and technicians can optimize production processes, save costs, and enhance overall efficiency. Moreover, this report underscores the profound significance of these machine tools in achieving product quality, performance, and reliability. They contribute to the creation of precise, flat surfaces, the carving of intricate groups, and the formation of diverse shapes. These functions are the bedrock of modern manufacturing excellence, and these machines are the artisans behind it all. In an ever evolving landscape of manufacturing technology, this report serves as a beacon of knowledge. It is a valuable resources of individuals seeking to harness the capabilities of milling, shaping, and planing machines. It not only highlights the importance of these machines, but also offers crucial insights into their working principles, mechanisms, and differences. As the industry continues to advance, this knowledge remains paramount in ensuring the continued success of manufacturing processes. Let this report remind us that behind every groundbreaking innovation and every meticulously crafted component, there are their silent workhorse, the milling, shaping, and planing machine, and their cutters. They are the foundation of modern manufacturing, and understanding them is the key to unlocking the potential of our industrial world. Thank you for your attention.